Hello everyone, in this video we're going to explore topic 4 concept approximating values of a function using local linearity and linearization. Alright, let's take a look at linear approximation. Suppose we have a function f of s and its tangent line drawn at a point a f of a as shown in the figure to the right. The equation of the tangent line, which we will call L of s, is given by the equation L of s minus f of a equals f prime of a times s minus a. And then I'm going to add f of a both sides. I get this one right here. This guy actually the point slope form formula. We have y minus y1 equals m times s minus s1, right? Where s1 y1 is given right here. Right, and the slope is going to be this guy right here, which means you need to take the derivative of this function and you plug s equal 8 over here, right? Near s equal 8, the function and the tangent line have nearly the same graph. If k were some s value very near to a, there would be very little difference in the values of Lk and Fk. In this case, we call the tangent line the linear approximation to the function at s equals a. Now let's take a look at the first example. Use the linear approximation for f of s equals cube root of s at s equals 8 to approximate cube root of 8.1. Alright, so basically we need to write the equation of the tangent line, right? We have y minus y1 equals m times s minus s1, right? Now we need to find s1 and y1, right? s1 is given right here, right? We substitute 8 for s into this equation to find y1, right? So I have f of 8 equals cube root of 8 is going to be 2, right? So then the point s1 y1 is 8, 2, right? Now I need to find the slope. In order to find the slope, I need to find the first derivative of this one, right? So I need to convert this one into the exponent first, right? So it can be f of s equals s power 1 over 3, right? So f prime of s, I'm going to use the power rule. It's going to be, now I need to find the slope, which is m equals f prime of h right here, right? So it turns out to be 1 over 3 cube root of 8 squared, right? So it could be 1 over 3 times 4, and it's going to be 1 over 12, right? So this one is the slope. So you have equation y minus y1, which means y minus 2 equal the slope is going to be 1 over 12 times s minus s1, right? So s minus s1 equals 8, right? Now I need to add 2 both sides, right? So it turns out to be y. Now y in this situation is going to be L of s, right? I just name differently, right? Equals 1 over 12 times s minus 8 plus 2, right? I need to approximate cube root of 8.1. So s in this situation is 8.1, right? So I need to calculate L of 8.1 equals 1 over 12 times 8.1 subtract 8 is going to be 0.1 plus 2, right? So the answer should be 12 1 over 120. Alright. Now let's move on to the example number 2. This one is calculator active. Using a calculator to find the error in using the linear approximation to f of s equals e to the s at s equals 0 to approximate 4 root of e. Now again, we need to calculate the first derivative of this one. So I have f prime of s is going to be e to the s, right? So then f prime of 0, right? S equals 0 right here, equals e to the 0 is going to be 1, right? So this one actually the slope, right? Now you need to find the coordinate point of s1 and y1, right? So s1, which is 0 right here, right? Y1 is f of 0, right? Now it turns out to be 0, f of 0 is going to be 1, right? I have the equation of the tangent line is going to be L of s equals the slope, which is 1, times s minus s1, which is 0, right? Plus y1 is 1, right? Now I'm going to simplify this one, is going to be s plus 1, right? So this one is L s, right? Now let's approximate 4 root of e. So I need to convert this one to exponent, right? So it could be e raised to the 1/4, right? So I have e to the s right here. This is the original function, right? So from here I can say that s equals 1/4, right? So I need to evaluate this one as s equals 1/4. It's going to be 1/4 plus 1, 1.25, right? Now we need to find the error. Error equals actual value subtract the estimated value, right? Now the actual value is going to be right here. We're going to print up the calculator. We need to hit control this button right here, right? So we need to put 4 root, right? 4 root of e. Hit enter. It's going to give you exact value, right? So you need to convert this one to decimal. Hit menu, number 2, number 1, right? Hit enter. The answer is right here. And then you take this one, you subtract 1.25, right? And hit enter. The answer is 0.034, right? Now let's move on to example number 3. For the tangent line to the graph f of s equals s squared minus 3s plus 5 at s equals 4 to have an error of at most 0.1 when approximating f of 4 plus h. Find the range of values for h. Again, you need to write the equation of the tangent line first, right? So I'm going to take the first derivative. It's going to be f prime of s equals 2s minus 3, right? I need to find the slope, right? So m equals f prime of 4, right? It's going to be 2 times 4 minus 3 is going to be 5, right? Now I need to find the coordinate point s1, y1, right? Which is s1 equals 4 right here, right? And y1, which means f of 4, right? So this guy turns out to be 4, comma what? Substitute 4 for s over here. So I have 16 minus 12 plus 5, right? So it could be 9. So you have the equation L of s equals the slope 5, s minus s1, s minus 4 plus y1 plus 9, right? You need to approximate this guy, right? So then s should be 4 plus h, right? So I need to calculate L of 4 plus h. It's going to be 5 times 4 plus h minus 4 plus 9. I'm going to simplify this guy. It turns out to be 5h plus 9, right? Now I need to calculate f of 4 plus h. So I'm going to use this equation right here, right? So it turns out to be 4 plus h squared minus 3 times 4 plus h plus 5, right? So it's gonna be 16 plus 8h plus h squared, right? I'm gonna use the complete square formula to expand this one. It could be a plus b all together. Square is gonna be a squared plus 2ab plus b squared, right? So it's gonna be negative 12 minus 3h plus 5, right? So it's gonna be h squared. 8h subtract 3h is gonna be 5h, right? Now 16 subtract 12 could be 4, 4 plus 5 is gonna be 9, right? So the error is gonna be the absolute value of the actual value subtract the estimated value, right? Now the actual value is gonna be right here. So it's gonna be absolute value of s squared plus 5h plus 9. Subtract estimated right here. 5h minus 9, right? And I simplify this guy, it's gonna be absolute value of s squared, right? So we want this one to be less than or equal to 0.1. Remember, at most is the same thing as less than or equal to, right? So we have absolute value of s squared less than or equal to 0.1, right? Now remember, if I have absolute value of s less than or equal to k, it turns out to be negative k less than or equal to s less than or equal to k. So keep this one in mind, right? So this guy turns out to be negative 0.1 less than or equal to s squared less than or equal to 0.1. But remember that anything square always greater than or equal to 0, right? So right here I need to put 0, right? Now I need to solve for h from this inequality, right? So I'm going to take square root both sides, right? So it's going to be control, and this one right here, 0.1. Hit enter, it's going to be 0.31228, right? Now remember, you have a formula s squared less than or equal to a. Then you have s greater than or equal to negative square root of a less than or equal to square root of a. By the way, if you have this formula s squared greater than or equal to a, then you have s greater than or equal to square root of a and s less than or equal to negative square root of a. Now let's move on to example number 4. The function f is twice differentiable. Select the values of f, f prime, and f double prime given in the table below. Let g of s equal f of s squared minus s. So again, we need to find the equation of the tangent line, right? So first, we need to find the derivative of g of s, right? Now we need to use the chain rule for this one, right? So we let u be s squared minus s, right? So then we have u prime times f prime of u, right? So this guy turns out to be u prime is going to be 2s minus 1, right? Times f prime of s squared minus s, right? Now I need to find g prime of 3, right? Right here. So this guy turns out to be, substitute 3 for s, so it could be 5 times f prime of 3 squared equals 9. 9 subtract 3 is going to be 6, right? Now f prime of 6, we're going to use this guy with f prime of 6, it's going to be 9, right? So 5 times 9 equals 45. And this guy actually the slope, right? Now as for 3, we need to find g of 3, right? G of 3 equals f of 6, right? Because 3 squared subtract 3 is going to be 6, right? So f of 6, we're going to use this one right here, negative 1, right? So the coordinate point should be 3, negative 1, right? So the equation of the tangent line is going to be L of s equals, the slope is going to be 45, right? Times s minus s1, which means s minus 3, right? And then plus y1, which means negative 1, right? Alright, now you need to calculate g of 3.1. So substitute 3.1 over here, right? So we have L of 3.1. It's gonna be 45 times 3.1 subtract 3 minus 1, right? So it's gonna be 45 times 0.1 minus 1, right? So it's gonna be 4.5 minus 1. It's gonna be 3.5, right? Now let's move on to the last example, AB calculus exam 2008, multiple choice question. The function f is twice differentiable with f of 2 equals 1, f prime of 2 equals 4, and f double prime of 2 equals 3. What is the value of approximation of f of 1.9 using the tangent line to the graph of f at s equal 2? Is the approximation underestimated or overestimated? Alright, so we need to find the equation of the tangent lines first, right? And we have the equation y minus y1 equals m times s minus s1, right? Now I need to find the slope first. The slope is given right here, 4, right? So this one is slope. Now the coordinate upon x1, y1 is given right here, right? So I have equation y minus y1, which means 1 equals 4 times s minus 2, right? So I need to convert this one to slope intercept form. So y equals 4s minus 8 plus 1 is going to be minus 7, right? Or L of s equals 4s minus 7, right? Now I need to substitute 1.9 for s, right? So I have L of 1.9 equals 4 times 1.9 subtract 7, right? So 4 times 1.9 is going to be 7.6 subtract 7 is going to be 0.6, right? So L of 1.9 is 0.6. Now we don't know how the graph of the function looks like, but we know that this guy right here, right? So you're gonna learn this one later, right? So if you have f prime of 2 is greater than 0, it tells us that the function f is increasing at s equals 2, right? Now f double prime of 2 is 3 greater than 0. It tells us that the function f is concave up at s equals 2, right? So if you graph this one, it's going to be something like this. The tangent line is under the graph. It tells us that this one is underestimated. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.